Hey, chemistry class, it's Hugh here. Good morning. It's May 28th on a Thursday. I'm just going to show you how to do these chemical calculations with reaction worksheet. And this will be posted as an assignment. The method I like to use with these kind of questions is a table method. And so here's a balanced equation. C3H8 plus 5O2 makes 3CO2, 4H2O. It's not lined up perfectly, but each of these should have its own column. In the table beneath the reaction, there are three rows: mass, molecular mass, and amount. Depending on what you're asked for, you put information in the first row and you work your way down to the bottom, across, and up. Let's see what this problem says. 25.00 grams of propane are combusted as shown. What mass of oxygen is required? What mass of carbon dioxide and water vapor are made? So let's start off. The 25.00 will go into the mass box for propane, C3H8. Okay. The molar masses, you need the periodic table. Here, carbon 12.01, oxygen 16, hydrogen is 1. Okay, 1.01. So let's just add them up. So C3H8 would be 3 times 12.01 and 8 times 1.01, and just zip it up in the calculator. $44.11. And that's a number that goes in the molecular mass, 44.11. And the units are here, so I'm not going to write the units down. Grams per mole. So again, molecular mass is the sum of the atomic masses. That's carbon and hydrogen, 3 carbons and 8 hydrogens. Okay. Now, we have to think about where we're trying to get to. In this problem, we're asked to find what mass of oxygen is required, so I need this box here. To get to this box, I can't go directly across. I have to go down and across and up. So to start with, I'll need to know the value of the amount in moles of carbon. Then I'll need to work out the amount of moles of oxygen. I'm going to need the molar mass of oxygen, and then I get my mass. May as well find this right now. So on the table, remember oxygen is 16. So O2 is going to be 16 plus 16 equals 32 grams per mole. Okay. All right, so now what we do is we want to figure out this box, and what we use is our standard equation. Amount is the mass divided by the molecular mass, and so it would be 25.00 divided by 44.11. So I get 0.566676. Now, I am allowed 4 significant figures, so 5667, round up 5668. Okay? So 0.5668 moles of the propane. Now, to get across here, you need to know how the ratio they combine in. The way this is set up, the way this reaction works is for every 1 propane molecule, you require 5 oxygens. So if I had 1 mole of it, I'd need 5 moles. If I had 2 moles, I'd need 10 moles. So clearly what you do is you multiply this number by 5. So on my calculator, it's going to take that number, go times 5. 2.834 moles of oxygen. Now, whenever I have 2 things in a column, I can find a third. I need to find mass. Mass is always equal to molecular mass times the amount So 32 times 2.834. So I'll just take this number here times 32. And I have 90.68 grams of oxygen needed. So the answer would be 90.6 grams of oxygen required to burn completely the 25 grams of the propane. If this was the only thing asked, then you're done. You don't need to know anything about the products unless it's asked for, but they do ask for it. It says, what's the mass of carbon dioxide and the mass of water vapor that are made? At this point, we peel back to here. We don't have to work our way down, but we do have to go across. So across and up, across and up. Okay? So to get these two boxes, again, do it quickly. We know carbon's 12.01, and 2 oxygens was 32, so 44.01. And oxygen 16 plus 1.01 plus 1.01 for water, 18.02. Now, we can think about this. For every 1 carbon, I produce 3 carbon, sorry, for every 1 propane, I produce 3 carbon dioxides. So whatever number here is multiplied by 3. So remember, I'm just putting this in to remind you, this was times 5. But now to go from here to here, it's 3 times. So 0.5668 times 3, 1.700. And we may as well do water as well. So for every one of these, we make 4 waters, 1 to 4. So I multiply the same number by 4.5668 times 4. 2.267 moles of water. Okay. Using this method, it's always down, across, and now up. Whenever you have 2 things, you can find the third. So it's simply the mass, always is a molar mass times the amount. Amount 1.7 times 44.01, and I have 74.82 grams. I rounded it, came up at 74.817. And finally, 18.02, put it in the calculator here, times 2.267, 40.85 grams. So now we know the entire equation. If you need to burn 25 grams of propane, you're going to need 90.68 grams of oxygen. You're going to produce 74.82 grams of carbon dioxide and 40.85 grams of water. Now, although it's not true you conserve, the number of moles changes, but the mass has to be the same. So the law of conservation of mass is always true. The total mass of both reactants should be the same as the total mass of both products. Let's just check it out and find out. Here's the 40.85. I'm going to add plus 74.82. I get a total of 115.67 total mass. Okay. If I go back to this side, 90.68 plus 25, 115.68. So it is. It's within that error due to rounding, and that's correct. So I hope this helps you understand how to do these problems. These are the type of problems you'll find all the time in computational chemistry. It lets us predict how much product we expect to get. It lets us predict how much of a reactant we're going to need to combine with a given reactant.